just sitting there like a bump on a log. Haley Shields. Yeah, whatever. Irrational numbers. An irrational number is a number that cannot be expressed as a improper or proper fraction. Okay, the book is going to say it's a number that cannot be written as a quotient of two integers. Okay, basically a fraction. Okay, a rational number is a number that can be expressed as an improper or proper fraction. Okay. Now, irrational numbers. Example of irrational numbers is the square root of 71. Okay, or the square root of 6, square root of 12, square root of 122. What do all those square roots have in common?
They're not perfect squares.
They're not perfect squares, okay? They're not perfect squares, and therefore all of these square roots have to approximate the square root. The reason they have to approximate them is because it is an infinite number. Okay? It means it's infinite. So let's look at those. First one we had was square root of 71. Okay? You can tell it just keeps going. Okay? Next one I had was what? Square root of 6. Just keeps going. Okay, it doesn't repeat. There's no repeating to it. It just keeps going. Square root of 122. Okay, doesn't have a pattern. Okay, 4, 5, 3, 6, 1, 0, 1, 7, 1. The ones don't repeat the same area. Okay, then the last one I had, was that it? 12, square root of 12. Okay, same thing there. So the fact that they don't repeat, they don't terminate, and they keep going infinitely means it's an irrational number. So any number that doesn't have a perfect square is going to be an irrational number. Okay, so the other types of irrational numbers that you will see will be like this. Okay, those are also irrational numbers. Okay, the reason they're irrational is because there is no repeating digit or block of digits, and it has several dots after the number that means the number continues forever. Okay. Now, understand that there's a difference between that and and that. Okay, that tells you that the 3 repeats. Okay, this is a rational number. So my examples of rational numbers are a lot more. Irrational numbers, 3/4, square root of 25, 1.6, 0.3 with a bar over it, 3 and 2/3, okay, 0.32, -6, okay. Those are all examples of rational numbers. Rational numbers are the numbers that you've been dealing with, since from a very young age. Okay? Now, so any questions on the difference between the two sets of numbers? Now, those two, rational numbers and irrational numbers, okay, make up the set of real numbers. Okay, you have irrational. Then over here we have whole numbers. We have integers. And then we have rational numbers. Okay, and that's what makes up the set of real numbers, rational and irrational numbers. Now, realistically, a lot of this is very simplistic. Okay, a lot of it's going to be either writing the word rational or irrational. Okay, look at number 3. Number 3 gives us 2/7. Well, the whole point of having a rational number is, can I write it as a fraction, basically? Well, isn't that a fraction?
Yeah.
So then it has to be rational. Look at number 4. Square root of 49. Well, the square root of 49 is what? 7. Can I write 7 as a fraction?
No. Or, well, yeah.
What? Yeah, there you go. So it's rational.
How do you know it's rational?
Huh?
How do you know it's rational?
If it's not a perfect square root, or it repeats forever, it's not rational. Everything else is rational. Don't remember what's rational, because there's a ton of rational. Just remember what irrational is. Okay, number 5. Number 5 says the negative square root of 71. Well, I don't care if it's negative or positive. Is there a perfect square of 71? No. So that is irrational. In other words, I can't take and write that number as a fraction. There's no way. Because it just keeps going and going and going and going and going. So what's the first way we put a decimal over a fraction? We have to identify its place value. Well, if the number continues forever, how can you ever put a place value in there? You can't, because it just goes on forever. Okay, so that's the reason it's irrational, because I can't put it as a fraction. I can take, for example, 0.65. 0.65 is a fraction. That's the hundredths place value, so that'd be 65 over 100. So that's rational. I can make it into a fraction. I can take 0.6 with a bar over it. 0.6 with a bar over it is 2/3. That's rational. Okay, because I can make it into a fraction. Okay. So number 6 says 8.34 with a bar over the 3.4. Is that rational or irrational? What? So I would circle this. Didn't I just say that 0.6 with a bar over it is a rational number? Okay, then 8.34 with a bar over it has to be a rational number. It doesn't go on forever without repeating. See, the irrational go on forever and they never repeat the same order of digits or the same block of digits or the same digit over and over. Okay, there's a difference. This is 8.34, 34, 34, 34, 34, 34, and it just keeps going. Okay? That's a rational number because I can take and put 8.34, I can make it as a fraction. Now, you don't know how because I don't teach the 5-step process for something you'll do twice in your entire lifetime. Okay, it's about a 5 or 6 step process to change that to a fraction, but you can. Okay, we just choose not to go over that because you will never use it. Okay, so that's how you do 3 through 6. Now number 7. Number 7 says copy and complete the statement using less than, greater than, or equal to. So, negative square root of 7, negative 2. Which is larger? Negative 2, why? Huh? Okay, why is the square root of 7 further away from 0? I don't know, do you?
Yeah, you do. But it's not a perfect square.
Okay, let me ask you this. Isn't this same as that? Okay, so no, equal to? How is it equal to?
7 is greater. Oh.
No.
Negative 4 is greater.
Negative 4 would be greater. The negative square root of 4 is greater because you are correct in what you said. If that's 1, that's 2, that's negative 1, negative 2, that's negative 3. Well, negative 2 is right here. Okay? The square root, and we'll just use our calculator here so we don't waste time. Basically, the square root of the negative square root of 7 is negative 2.6. So it falls right there. So that would be the negative square root of 7. This would be negative 2. So the one that's closer to 0 is greater. So therefore, yes. Yeah, if the negative sign was not in front of the radical or the square root sign, then the square root of 7 would be larger. Or if neither one, if it was this, then the square root of 7 is bigger. Okay, if neither one of them had the negative sign with it. Okay, do number 8 on your own. Square root of 11, square root of 9. Now I want to know if it's is less than sign, is greater than sign, or is equal sign. Haley? Huh? So what goes in the blank? The greater than sign, is less than sign, or is equal to sign? Greater than. Okay? So, like I said, not real difficult. Number 9, says the square root of 16 and 8 over 3. Well, what is 8 over 3 as a mixed number? Not everybody at once. 2 and 2/3. So what is the square root of 16?
4.
So which one's bigger? 4. Because you take 3 and divide it into 8, goes twice, be 6, remainder 2, take the 2, put it over the 3 for 2 and 2/3. And this is 4. Okay, so that's pretty simplistic. Now, I want to look at something. We have not talked about these. Let's see here. Square root of 1.44. Okay, here's how you take the square root of a decimal, if you just don't know it. Okay, the way you take the square root of a decimal is you take this decimal number and you make it a fraction. So that's 144 over 100. That's what 1.44, because that is the hundredths place value. So I take the square root of 144 over 100. So that means, from what we learned in section 2, the square root of 144 over the square root of 100. 12 over what? 12 over 10. Is that irrational or irrational? It's rational. Okay, now let's look at another one. Square root of 14.4. Well, that is 144 over 10. That's the square root of 144. That's the square root of 10. Do you have a square root of 10? No. So that is irrational. Because that's the tenths place value. Huh? No. There's only one place behind the decimal. There is 2 places behind the decimal there. Because it's still 144. If I make, in other words, to make this right here, I have to do that. If I do that, that goes once, 10, remainder 4, bring down my 4. 10 into 44 goes 4 times, be 40, remainder 4. There's my decimal. Bring down a 0. 10 into 40 goes 4 times. Huh? Doesn't matter if it's negative or positive. Had nothing to do with it. Doesn't matter the sign in front. Irrational and rational can apply to positive and negative numbers both. So that one is irrational, because there is not a square root of 10 on the bottom of that fraction. No. I'm just working it out and proving why it's irrational. All right, now let's say we had to order these numbers. 3.5, 2 times the square root of 3, square root of 13, 19 over 5. Wow, they gave me a whole host of them here. 3 1/4, square root of 8. They want us to order those from least to greatest. Okay, so I'm going to get them all in decimal form. 3.5. Okay, I'm going to let you use your calculator on these. Here's how you would do it. 2 times, okay, square root, I didn't want to do that. Got to do the 3 first. 2 times, clear, no, thank you. Do what? Okay, 2 times square root 3 is 1.73. So that's 1.73. Square root of 13, it's going to be between 3 and 4. So I'm going to let, like I said, you can use your calculators here. 3.6. 19 over 5 would be 3 and 4/5, so that's 3.8. That's 3.25. Square root of 8. Anybody know the square root of 8? 2.82.
How is 19, how can you do 19 over 5? 5 is the,
What?
how can you do 19 over 5?
How did I do it?
Yeah.
5 goes into 19 3 times with a remainder of 4. 3 and 4/5.
Then how is it 3.8?
4/5 is 0.8 because I have them memorized. Because I memorized those that, I've told y'all to memorize. Yeah, there's boxes that said you might want to memorize these back in like chapter 2. And I see that y'all took it to heart there. Bottom line is you can use your calculator and just do this. 19 divided by 5. Keeps putting that 2 up there. I don't want the 2 up there. 3.8. Okay, so we put them in order now using their original number. So it gives me 2 times the square root of 3. And then that's going to give me square root of 8. That's going to give me 3.25, 3 1/4. So I've used that one, and that one. So $3.50 is less than $3.25. Next one is 3.5. Next one is square root of 13. Next one is 19 over 5. Hmm? 3.5 is the same thing as 3.50. Okay. Sorry, I didn't know I was going to have to do first grade math for us today. Okay, do they have the same amount of digits? Okay, so I've got to make them have the same amount of digits. So you have 3.500 or 3.250. And look. If you look at it this way, stack them on top of each other like that, the 3's are obviously already the same. Which is larger, 5 or 2? So it's got to be the larger number. Because it doesn't matter how many digits it has. I can write that, and then I can do this. Doesn't matter. The amount of digits doesn't matter. It matters when you stack them vertically, which is going to be larger. Well, that's larger because it's large. 3's larger than 2. So it doesn't matter how many digits it has. It matters when you're lining them up, which ones are which. Okay. So your homework is 9.4, 3 through 25. Originally it was going to, oops, hang on here. Yeah, originally I was going to do through 33, but. Well, let's not get carried away. All right. So, obviously, on most of it, you're just, we've already done 1 through 10. Okay. 12 through 19, you're just putting irrational or rational. We've already done I haven't done 2 of the 20 through 23. I did some parts of them. Okay, so you basically have about 6 problems, 7 problems you got to do. Because we've already done all the rest of them.